Hello and good morning, and thank you so much for joining me in my shop. Today is May 28th, 2024, and it's my first day with this radio. And since this is a #1 video, or first video in a series on radios, you could be a new viewer, so I just let you know a few things about how I do these videos. First of all, you know as much about this radio at this point as I know. There it is. What a fantastic looking radio. I haven't done anything to this radio except stick it on my bench, and that's how virtually all my videos start, without me really having a clue. And sometimes it continues that way too. I should warn you. I'm doing basically live videos here. There'll be very little editing, and all I really edit are some rough transitions between shots. That's all I really edit. So as I work along fixing up the radio, you're going to hear me babble and talk. I'm going to say some half-brain things because I'm thinking about what I'm doing and my mouth is still going maybe when it shouldn't. I'm going to want to tell you the thing is red and the word blue is going to come out of my mouth for some reason. I won't even know it that's happened. So this is not a scripted presentation in any way, not a training course. I'm not trying to teach anybody anything. Well, I'm trying to teach myself how to do this, but you're quite welcome to come along for the ride. That's basically so you've been warned. Keep your thinking cap on, and be doubtful about the things I say. Don't consider me to be the be-all and end-all authority on anything at all. There you go. Another thing you should know is that I do take steps to maintain my safety here in my shop, and I may mention a few of them as I'm working along, and you may become aware of them. But if you're doing this kind of stuff, your safety is your business and your responsibility, not mine. And so don't look to what I'm doing here as an explanation of how to do things safely, although I am trying to do things safely. Okay, all that having been said, let's take a look at this radio. So what a fantastic looking radio. Holy smokes, that is just the coolest looking thing. It's a FADA, and you can see the word FADA written right there. And the numbering is a very interesting style of numbering, kind of a mod 50s look. I'm not too sure just how to explain that. A little hard to read the numbers with the band they drew on here. That's actually a slot through which I guess you can see the pointer. There it is, right around the 100. You can see the pointer moving back and forth. That's pretty hard to see. Maybe when the radio's on, there's a light that's making that much easier to see. So I'm already checking the radio's tuning. It feels great. So I'm looking for a string tangling up or anything like that. No, very good. Excellent. Well, I've passed the first test. Let's take a look at the back here. So usually there's a lot written on the back of these radios. It looks like there never was anything written on this one. Now I see some rivets here, and I see some brass screws here. This one looks really roughed up. So I can feel there's a loop antenna running around inside here, which is quite common. But the rivets tell me that this back is connected or screwed or bolted onto the chassis here. So I'm not going to bother with loosening off these screws. I don't think it's a good idea. I think you can see there are bottom screws down here that I can remove, and I can pull the chassis out. My aim with these radios right off the bat is to get them operating. Get them plugged in and get them operating before doing any kind of work on them. Occasionally you can't do that. There's something seriously wrong and obviously wrong with the radio. It's got to be fixed right away. But what I want to get is a radio working to some degree, and by that I mean if you touch the antenna wire, you hear some variation in the speaker. It doesn't even have to pick up a station. Just has to kind of work through. As soon as that happens, as soon as you, in my mind anyway, you've got reassurance of a whole bunch of things about the coils and stuff like that in the radio, if you can get it to do that. Until then, if the radio doesn't respond to touching the antenna, if there's no response or no operation whatsoever, a little bit of a high anxiety to go ahead and start working on the radio and doing things to it, for fear of making simple, innocent errors and just multiplying the complexity of the problem, whatever it might be in the radio. So eventually we're going to plug this in and see if it works. And I suspect it does. And I can't remember now what I was told. I was told something. I don't remember what it was. And by the way, if you're watching my videos as I post them, you'll notice that very unusually I didn't post any videos for the last, maybe one video over the last 4 or 5 days. I took a vacation. I went up to the city of Ottawa in Canada here. Oh, that's funny. Well, what's funny is they look like 1/4-inch screws, but yeah, I went up to the city of Ottawa for a few days for a vacation, my wife and I. What a wonderful city that is. If you're a tourist in this part of Canada, you have to go to, if you're a tourist, you're not likely watching this video. If you were to tour Canada, Ottawa is a city well worth going to. Absolutely. Beautiful city. Okay, one screw left here. Let's see if the radio... I've got the radio on its side, so the insides may fall or drop a bit. That's okay. Now, is that a crack in this cabinet I see here? No, it's a hair. I haven't seen any cracks yet. So this material... perspiration from my hand. I mean, it's all mottled in here, but it doesn't look like Bakelite to me. But maybe it is. It's an interesting color. Let's just drop this out now. Oh, pull these knobs off. Okay, there it goes. Most of the dial face is going to stay in the cabinet here. There we are. Okay, let's examine the cabinet a little more carefully. So you can see that the front is darkened because here where the knob was, it was protecting it. You can see the top. Well, that's kind of odd. Now the top is what would be exposed mostly. Why didn't this go dark? I don't know. I don't know why it's changed the color the way it has. You can look inside. Feels like Bakelite. It has that nice smooth feel, very rigid. It's fairly thick. It's a great cabinet. No sign of cracking or any kind of deterioration at all, other than the color change. Beautiful. Okay, let me set this aside. Or I won't break it. Let's take a look at what we've got here. Okay, I'm not the first person to have this radio out of its cabinet, that's for sure. It's very, very clean under here. It's very clean. I don't think it could have just lived its life and ended up looking like this. Somebody has cleaned this. There's all these excess wires in here, or replacement wires. Not sure what this white one is. Lovely shape though. Okay, let's take a look underneath. So underneath we see replacements here, nicely done. I can see the workmanship is nice. These are loose. I think they're, well, he's got a tie wrap to try to hold them up in the radio. So these are the replacement capacitors for the filter capacitors. And I am looking, this might be a replacement resistor here. It looks a little cooked. Here we have replacement capacitors here. So this guy's had, I believe he's had a total restoration job done. And what I mean by that is there's a capacitor back there. that's been left in, a wax capacitor. That's a replacement. These two are replacements. Those two are replacements. That's a replacement. That's a replacement. Why not this one? Isn't that curious? Why they would leave one? We do all this work and leave one. It's possible. Never saw it. It's tucked way up in there. Not likely. Probably left in for some reason. This looks like a replacement cord. Let's look at the cord end here. So the plug is a polarized plug. It has a wider prong. That's certainly not original. And this kind of clear plastic cord, you never see these on as an original cord. So it's been replaced. Looks like a nice job done again. Let's just double check where he's put the. So I'm feeling on the wire for which side is ribbed. This is the ribbed side, and it's going to the wide prong. So the grounded side is ribbed here. It's a little tough to feel it here. Feels like the other leg, the live leg. Yeah, I'm pretty sure that's what this has come to the switch. So he's switching the live leg. This is a 5-tube radio. It has no transformer. The tubes are all in series. These look like Lochtel tubes. There's a lot of them. 1, 2, 3, 4, 5, 6 tubes. This is a 6-tube radio. This is potentially a really good operating radio. You can see the tuning capacitor has 2 different sizes of tuning sections. It's worth noting. It's got a couple of adjustments here, and the IFs have capacitors adjusted from the top. There's probably nothing underneath to adjust. Down here, all done from the top. Makes it all easy when it comes time to do the alignment. I have a light at the top with a directive metal shield or cowling on it. Try to aim the light, or maybe prevent it from casting out. The whole cabin is translucent, so if you get too much of this light casting out, I suppose it's going to look funny. Now, what's with this white wire, which is connected here to this purple wire? There's a little excess purple wire that's been looped around, and it comes up to the tuning capacitor. So this would look like if you wanted to hook up a wire antenna to this radio, you would hook it up to this wire. But it's hidden inside the radio. It's not doing any good. And I wouldn't really recommend anybody try hooking up a wire to one of these radios. If it has a loop antenna, that's really what you want to work with. Excuse me. Okay. Certainly this radio is in good condition for testing, for plugging in and turning on. I'm not at all anxious about doing it. But I'm going to have a little bit of coffee, and then we're going to try the radio out and see that it works. It probably does work. There may be very little or almost nothing for me to do with this radio except admire it and have some fun with it. Now, that sounds alright. Okay, I mentioned I do some things in here to keep things safe. One of the things I do, it's not so much a safety thing, is in starting up a radio like this, when you don't really know anything about it, you just kind of looked at it, it looks okay. How do you know? You don't know. So plugging in here is plugging into the output of this device. This is an isolation transformer with a variable voltage setting control on it. A lot of people doing this kind of work would rely on a unit like this, but I actually like an even simpler thing, which are these light bulbs up above here. So what I do is I'm going to power this up. Maybe there's a short circuit in it, or something's going to happen. I don't want, the full power to reach the radio. I send the power through these light bulbs. These are incandescent light bulbs. They just have a hot filament in them. Just old style light bulbs. Can't believe I'm even saying that. And electricity goes through the light on its way here. So what that does is it restricts the amount of power that's going to come to the radio. If the radio had a full-blown dead short in it, the light would come on in its normal full brightness, nothing bad would happen. I would just be turning this light on, basically. Well, what that would do is A, a bright light tells me something's gone wrong, and B, stops my fuses from blowing, a circuit breaker from opening, or some very large current going into something that's shorted. Maybe my fuse isn't going to blow, maybe it's going to set a fire or something like that. So that's one of the things I'm doing in my shop. That's called a dim bulb system. I'm sure you can go on the internet and find more information about it. It doesn't get any simpler. Cobble it together out of some junk parts in your house. So over here I have a switch panel which you're going to hear the sound of. If you've watched lots of my videos, you already know the sound. So this is the main power switch. We're controlling power here, and then this is a selector switch. If I flip it down, power going through the lights to come over to the project, come over to here. Flip it up, direct connection to a nuclear power plant not far from here. So there'll be a nuclear power operating this radio. Yeah. And a little bit from Niagara Falls would probably make it here too. Okay, turn that off. So we're plugged in. Incidentally, this is powered by a 2-wire extension cord. There's no ground brought over here at all. This has a ground terminal, but don't be fooled in my shop if you're watching. The ground terminal is just sticking out here. The whole system here is ungrounded. I'm using an isolation transformer. Actually, behind this guy, there's another isolation transformer. Can you believe it? And so I'm double isolated transformered here. And what that does is it means there's no propensity for electricity to travel from this cord or the output of this, however you want to look at it, into the earth. There's no circuit there whatsoever. This circuit is isolated from ground. Now that means I'm standing on the ground, I touch something grounded like this stuff. I shouldn't get a shock coming from power here. That gets me a little bit of safety here. So isolation transformers, you can read up on it. With a 5-tube radio, this becomes quite important because of the hot chassis problem, which you can read up on too. If you don't know what I'm talking about and you're going to be doing this kind of work with these little radios, you think the little radios are the better ones to start with, and maybe they are. If they don't have a transformer, they have a danger, and it's called hot chassis problem. Look it up and read and study. And there's lots of excellent resources on the internet. So I'm doing a few little safety comments here because this is video number 1. And some of you may be a new viewer, and I'm just a little bit concerned that it may not look like I'm taking care when I actually am. So, okay, we're ready to power this guy up. So first thing we'll do is we'll turn it off. We're going to apply power. You can hear the switches go. Now watch these lights. Watch this thing. And there's a couple other meters jumping around too. So 108 volts is what we're trying to supply the radio. That's what's at the outlet here, 108 volts. The radio's not operating, of course, because it's turned off. The dim bulbs did not come on. I think only this light is screwed in right now. Okay, so now we're going to turn the power off, turn the radio on, move the volume up, I don't know, 20 degrees or 30 degrees. I'm going to turn the power on. If this radio was not worked on, what I would expect is probably a hum's going to come out of it pretty quick. Since this radio's been worked on, I suspect it's just going to operate just fine. That's what I'm really anticipating here. What that'll do is, when you first turn it on, the heaters in these tubes are cold. So the current goes through them quickly because the resistance is low. So that causes like a rush of current or a heavy flow initially. The heavy flow will be reflected in the light bulb here. You'll see it come on pretty bright. And then it'll dull down fairly quickly as these heaters heat up. As they heat up, the resistance goes up, the current going into them goes down. As it goes down, this will get duller and duller. But then another thing happens in these radios. The rectifier tube, once it's operating, will start generating, or maybe not, you'll start rectifying producing. None of those words are right. high voltage will develop in the radio, let's put it that way. High voltage will start all these tubes operating. Each one of them will draw a little bit of current, and that'll cause the light to come up again. So the light is going to come on bright, go down, wait a while things heat up, and then it's going to come up half bright and sit there. The voltage here will be something like 80 volts. The rest of it will be dropping there. Maybe this will be 100 volts. The rest dropping there at 20 volts or something like that. Or actually, we were starting out with 108. So, but then if everything's looking good, I will raise the voltage here by screwing in the light bulb. This thing will have enough voltage to operate normally. Still have these bulbs in case something happens, rather than the direct connection to some generator bus at a nuclear power plant. At the Bruce Nuclear Power Plant. Not too far from here. Okay. I think we're ready. Here we go. Watching the lights now. Bright. Very bright. Staying bright. Going down. Going down. Sometimes when you do this, the bulb robs so much power from the radio, the tubes heat up very slowly. So it takes a little bit of time. So it's still going down. Voltage on the radio is only 65 volts. That may not be enough for it to even operate. The behavior is normal but slow. Still going down. But very soon it will start coming up again. 68 volts here is awfully low, so I am going to screw in the second bulb. That'll raise this up to probably 100, probably the full. This light will go dull, or go off. I'm having trouble speaking. See, I've got some coffee, but I haven't drank any of it yet. Here we are. Oh, I hear a radio. Okay, now that staticky sound is normal in my shop. 100 volts, perfect. Okay. What do you do, Mr. Radio? Guaranteed high is 19. 19 degrees. Very cool. It should be a little warmer here, I think. In Canada, people pay close attention to weather reports. I don't know. I suppose it's similar in other parts of the world, but the weather here comes and goes so fast and is so particular to the location you're in. I guess all weather is particular to the location you're in. So that's 68, 680. $640. I apologize for that interference. I'm attempting to correct it. Now, let me get this. So I have a commercial loop antenna here, which is resonant, has a tuning knob. Can make this thing resonant at the frequency that we're listening to, put it near this antenna, and this thing will boost it a bit. Let's see if it's true. Put it right up here. But we need the station. That's without it. And I'll tune it. And aim it. This is 590, the sports channel. So unfortunately, we really can't make this radio work much better than that here in my shop, but I'll bet you outdoors this is working really quite well, or away from my noisy shop. I think what we'll do next is we will check its alignment, because I don't think there's anything else for me to do here. We'll check the scale alignment and whatnot and see if we can peak up the performance a little bit. But I don't think I'm going to do too much to this radio. I think it's in really good shape. And the last thing I want to do is unshape it by fooling with it. Coffee time here. Okay, I found a couple interesting things about the radio here just by hunting around on the internet for a few minutes. And this is a Radio Museum website, and that clearly is the correct radio. It turns out it's a FADA 659 temple radio. So its name is Temple Radio. Look like a temple? I don't get that name, but unfortunately there's no circuit diagram here. Just photographs, and like these are all brown. This one's gold. Here's some sales pages on it, and I also found this. If you can read here, this might be a little small on your computer. It says Model 659 2-wave. No, this is not a 2-wave. This can't be 659. What did I say it was a 659? 659. 5 circuits. Broadcast and short wave. So I do not have a 659. Yeah, there's a short wave band here. Let me check. I can't see how there could be. No, there certainly isn't. No, so I have an AM only model. So it's a 650 something else. Got the wrong number here. I thought it was a 650. Okay, so anyway, let's just carry on with what I've got here, even though it's not quite what I thought. Let's go back over here. 659, 2 waveband super heterodyne American and foreign reception. The short wave is referring to foreign reception. A choice of 5 colors, gem-like FADA-lucent cabinets. Yeah, FADA-lucent. Yeah, that cabinet would qualify for that, I guess. Operates 105, 125, same voltage DC, 2 wave bands, no, just 1 on mine. And I'm just wondering if it's just going to give the IF frequency there. It does not. Noise reducing FADA sensitive tone RF stage. Wonder what that's all about. We can't know without some kind of a schematic, so don't have it yet. Yeah, just keep looking a little more for it. Okay, so I'm just searching on Microsoft here on the Bing search, FADA schematics 659. This page has come up, and if we look at it, 659. Now mine's not a 659, but it's very similar. And here you can see in bold print IF 456. So that's just what I was looking for. Okay, with that information we can carry on with the radio. Okay, we're going to use this signal generator. We're going to dial up that IF frequency of 659 kilohertz. 459. 456. Yeah, I'm only partway through the coffee cup so far this morning. We need a loop. Here. So the signal generator will drive this loop, and I'll just put this near the radio antenna. Now my frequency counter is taking a little bit of time here to settle down. It's got its problems. So this will stop in a moment. Oh, it almost stopped there. Why it does this exactly? There we are. And it happened to be dialed in right on 456. Just a coincidence. Must be the last thing I was doing. Can you hear a tone coming out of the radio? Let me tune it off the station. Quiet spot. Here we are. Hear the tone coming from the signal generator. What I'm going to do is I'm going to vary the frequency up and down from 456. We're going to listen to whether the tone gets louder or quieter, or what happens to it. I'm just going to move the camera over here. did this radio get nicely tuned up? Here we go. I think it needs a bit of help. Seems pretty broad and kind of down in this range. Doesn't seem like it's tuned up quite properly. So let's put this on 455. When this says 455, the signal generator is actually at 456 or so. And now what I'm going to do is I'm going to adjust, just based on my ear hearing the sound coming out of the speaker, the 4IF. Yeah, you see how much louder it got? Now normally you would do this with a voltmeter hooked up to the speaker or some other method, but I'm just using my ears. Well, ears and my brain too. Seems a little better to me. Okay, so now we're gonna get this away. We'll tune and see if it's a little better. Okay, one of the things I want to do is I want to remove this piece of wire. It's not helping matters at all. So I'm going to cut it off here. Didn't seem to make any difference, did it? We're going to pull it out. It's best with these radios to rely on the loop antenna, I believe. The wire antenna is just going to get you a whole bunch of noise, I'm pretty sure. The loop antenna is resonant. I can kind of pull the signal out. Now, we also have some pretty long wires in here wrapped around this bracket. Probably wrapped around the bracket just to secure them, but really this should just be right to here. It should not be so long. The other wire, the orange one, looks like it's going to the chassis here. Nope, it's going right inside the radio somewhere. That's a little strange. Where's that orange wire going down there? That's this orange wire here, coming from the loop antenna, rather than going onto the chassis. It's going in. It's probably going in and finding the B- line is probably what it's finding. This is a little interesting here too. So we have this wire coming down from the frame of the chassis. Instead of just being soldered to the top, it goes down under and gets soldered. And it looks like this might be the same piece of wire coming back over the top. It's soldered on the top and the bottom. Or am I just making all this up? I think I'm making all this up. Can't see it from here. And look at that. It's another adjustment here. Hey, what's that all about? So the capacitor is two different sizes of capacitor plates. So the oscillator is a little bit smaller. That eliminates the need for a FADA type capacitor in series with it. Some radios, the size of these two elements is the very same, but the frequency of operation is separated by the IF frequency. So to compensate for variations in linearity, they stick a capacitor in series with it. So this would be a local oscillator type adjustment here. I'm not adjusting it. I'm just wiggling the screwdriver in case you're wondering what I'm doing. You really need this guy back in its cabinet to see where the pointer is. some other method of identifying where it's tuned. There's nothing marked on the back. I don't have a schematic, so there's no instructions. Sometimes there's instructions on how to do this without the dial face. If I put this back in the cabinet, can't really access these. You might be able to, actually. Oh, no, can't get your hand in past here. No, you'd have to take this down, and then you're starting to disturb the whole thing. Kind of not the way to go. And what am I trying to do? Accurate dial, maximum sensitivity. Okay, so let's try this. Normally, the adjustment I'm going to do is done at the high end, but I'm going to do it at somewhere down here once I get a station. So right there I've nulled out the station with the antenna this way. So I'm just going to flip it 90 degrees. Got to be the maximum. And I'm going to adjust, not the local oscillator, with the antenna here. And my guess is we won't get any benefit from this. Okay, here we go. Bad guess. No. About like that. Maximum about like that. Well, performance is improved. Let's see what we can do about the local oscillator now. So I'm going to bring the cabinet in here. I'm not going to put the cabinet on. I'm going to do something a little crazy here and try to just look through it and see the pointer. Yeah, the parallax is horrendous, so I can't be sure of anything here. Yeah, it's not going to provide any accuracy. So I'm going to slip it in. I don't want to do it with it operating. The reason is your fingers can slip under the chassis a little bit when you're doing this kind of stuff. Can't pay attention to everything. And don't need that excitement in my life. Okay, there we go. Now it's in. Now we're going to want to get a close look at the pointer here. It might be a little tough with this particular camera. Okay, we'll make sure these knobs are in the center of the hole, so that'll make sure the radio is positioned properly. Because the chassis can slide around, that moves the pointer. Okay, power back on. You didn't see it, I don't think, but you could see the light here. Yeah, you can't. I can see it, but it's not really coming up in the camera. Oh, maybe there. You see it more on the top. Now it's a little brighter. You can really see the spot here. This might cause a brown spot here in the long run. It doesn't seem to be lighting this very well. Let me douse the lights in here for a bit. Complete dosage. There we are. So this is the top part here is really glowing, but this is lit up pretty nice. Okay, lights back on. Some of the lights anyway. Now, what are we listening to? So that was a station at 590 being picked up around 610. So I've moved the pointer to 590. We want that same station to come back in now. Okay, so we're gonna, without tuning the radio at all, we're gonna dump it out the back here. Okay. The reason I'm doing it this way is because this is where all the stations are that people would normally listen to with this radio in this area. So what's going on at the high end, not so important, but down here there's like 3 or 4 different stations that can be tuned, and they're all fairly close together, so getting the pointer accurate here is worthwhile. Turn it back on here, Jim. Get her warmed up. So I'm now going to adjust the local oscillator here and try to bring in that station without touching the tuning dial, Jim. Okay, and the maximum was about here, I think. Can we find it? Ooh. It's not going anywhere. That didn't quite work out. Let me, is there some, well, maybe it's that, you know what it is? I think I need to tune the other capacitor, the one I discovered sticking out under the bottom here. So what I'm going to do, because sooner or later I'm going to tune this radio by accident. I'm going to put a mark on it, showing where 680 should, or 590 should be. Right there. Okay. Don't be fooled by the parallax. Now, I may have to, in the end, do a proper alignment job with these 2 adjustments. Let's see if this one will move it around a little better. There we go. Oh yeah. I don't know. It doesn't seem right to me. What's happening here? It doesn't seem like it's tuning it. So this should be moving the local oscillator around as I do this. We're going to take another approach to this. I'm going to use SDR radio to detect the frequency of the local oscillator and adjust the local oscillator based on its position as shown in the SDR. So first step for doing that is go drink some more coffee. Okay, sorry about the noise the radio is making, but we have to have the radio operating while I'm doing this. Now, I've got a pickup coil, I'll show you in a few minutes, located just kind of above the local oscillator amplifier tube, if I can call it that. And it's picking up a local oscillator. One of these signals is the local oscillator of the radio. Now I'm going to figure out which one by tuning the radio a little bit, and we should, there it is. You see it moving around. That's me tuning the radio. So now, if we want the radio to be tuned to 590, and the IF is 455, let's use. So then we would want, let's see, it'd be 600 plus 445, that's 1045. So the local oscillator should be at 1045 when the radio is tuned to 590. So which one again? Okay, so that one there. And I'm going to tune the radio based on that piece of paper mark I made. There we are. And where are we? Are we at? So we're off. We're off by quite a bit here. It should be, I'll put this where it should be. 45. Should be there, where this red line is now. So now I'm going to try to adjust its location by turning the trimmer, the patter that was located under the chassis, Okay, putting in a screwdriver, and now I'm moving it. It's not going anywhere. It's not going anywhere. Oh, the screwdriver came out. Okay, get the screwdriver in. So I may be missing, I'm guessing what these trimmers are. So nothing's happening. I'm moving it. Okay. That's the one that was under the chassis. This is the one that's right on top of the capacitor. This has got to be the one that moves the local oscillator. Here we go. Yeah. So we want it way up here. Oh boy. So I've opened the capacitor. It really can't get much more open than this. In fact, turning the screw doesn't push it further. So that's pretty close. Where are we actually now? We're not. So let me just move this over here a bit. Okay, so we're at 440. So yeah, we're off by just a little bit. But we should be hearing 590 at this point. I don't hear anything. What have we done here? Okay, let's leave this. We'll go back to the radio itself, or at least the camera on the radio. We're lined up. Okay, so this was the pickup coil. It's just a clip lead coiled up and just put near the radio. Sometimes you can pick the local oscillator up a couple feet away from these radios. Where's that station? Let me get my boosting antenna. Where? Don't tune it. Put your fingers under the chassis. So there's 590. It's over here. Always possible I've got this point not quite in the right spot. Let's move it to the right spot. So there's my screwdriver. And you might think using a great big screwdriver like this will throw the radio off, and sometimes it will, but this one, no. Okay. Oh, that's right. I can't get it any further. This is the limit. And what is this thing for down here? Could be it affects the local oscillator at the high end. And then let's just check this. This is the antenna tuner. Not much difference in any case. Okay, we're going to try another antenna boosting technique here. See if we can get a little more out of this radio. It's a little easier to listen to. So what I've done is I have an outdoor antenna. It's coming in on this cable. This cable is connected to this loop now. So rather than receiving with this loop, I'm actually kind of transmitting out of this loop the signal that's coming from the outdoor antenna. Then it's passing through the air into the loop of the radio. So I'm just providing it with a much better source And you can see sounds a lot better, right? If I move this away, we're back to that. I kind of thought I could tune this too. Doesn't seem to matter if they tune the loop. A little surprising to me. Let me just turn off the... Yeah. There's no doubt it's helping. Get it up close. I wish that noise would go away, but so far my wishing hasn't worked. Checking again. If I take this to another location, this noise will disappear and you just hear the station clearly. That's what would happen. So let's just check something. Nope, not those lights. Yes, I'm on a perpetual hunt for sources of noise in my house. Let's just tune across the band now. So this is 860 here, French CBC. Oh, this is not doing too bad. It's doing quite well. Hard to pick stations up in the high end here. Take away this booster, there's nothing left. See, that noise is coming in on my antenna. Okay, a little experiment. I'm going to go and try and shut off what I think is the noise source here. Yeah, that didn't make any difference. So, perpetual hunting for sources of noise in my house. That's really good. That's actually really good. Even though I've got to boost it with this antenna here. Can we make it any better? Probably not. What is this thing doing down here? Wow. Oh, it's in Chinese. So this is a community radio station in Toronto. Not a strong signal at all, and I'm getting it. Very good. Excellent. Let's go back down here. Oh my gosh. How'd it get so much better? This thing? Oh my. Where'd the noise go? This antenna by itself now in my shop. Oh, see, it really needs the boost down here. Well, I'm just fiddling around now. I'm not going to get any more performance out of this radio. This is very good the way it is. No need for me to do any kind of further work with it. Just a tuning up of the IF, fiddling around with the local oscillator a little bit, and fiddling around with this last adjustment, which must not be a local oscillator adjustment. Must be something to do with the loop antenna, I guess. Not sure. Anyway, there we go. That's the end for this radio. Certainly outside of my shop, in a better environment, this will work quite nicely. And it does have 6 tubes, which usually indicates it's got an extra front end tube, which makes the radio much better than a 5-tube radio would be. So there we are, the FADA. I'll put it back in this cabinet. We'll take a last look at it. Okay, just a couple things about putting in these kinds of screws that are holding the cabinet in. Don't tighten these things up. Just make them nice and snug, but no tightness, because that'll put a strain in the plastic and maybe lead to a crack. Now this is a kind of plastic called Catlin or Catlin, and very desirable. It has a looks a little bit like Bakelite because of the modeling, but it gives it a beautiful look. And judging from this radio alone, this is pretty thick too. This is awfully thick. It's in perfect shape. Maybe the color's going a little off, but you know, that's hardly something to complain about, because if anything, it's looking better and better as the color shifts in it. So wonderful radio, no doubt about it. Definitely a collectible radio. The person who owns this guy is a radio collector, and she's got a pretty good eye. She's collected quite a number, I don't know how many, not quite a number. She's collected a few very nice radios, this being one of them. So fantastic. Well, thanks a lot for watching. I didn't see a lot of electronic work here on this particular video, but then I never know when I do these. I never know what to expect. Yeah, so great. Well, tomorrow I'll find some other radio to bring in here, and we'll get busy on that. I think the next project is going to be a lot of work. That's what I imagine. Thanks a lot for watching, and enjoy your day, and see you.